number 39. Redraw the motion diagram shown here, then draw a vector beside it to show the direction of the net force acting on the object. So the net force. One of the things that comes in really handy is to be ready to think about Newton's second law. Total force, net force, equals m times a, and that means that the total force is proportional to the acceleration. So if the acceleration is up, well, then that means total force is up. If acceleration is to the right, well, then total force is to the right. They're proportional to each other. So what we really kind of need to look at from what we've got here, one of the things that's helpful is to look at the acceleration. Which direction is the acceleration? So the way these arrows are going, this is where we start up on top. This is where we finish. The arrows are all pointing down, so we're saying it has this velocity here. Then when it's at this location, it has this velocity. When it's at this location, it has that velocity. When it's at this location, it has this velocity. So that's what we're talking about. Whoa, hey now. All right, we'll have to do some editing there. So this last data point, we're going to ignore. That's one that is sometimes included unintentionally or by mistake, and the editors don't quite catch it, because at this point then the arrow should really be much larger again. So this object in the beginning has a tiny velocity down, and the last one that has a legit arrow is here, big velocity arrow going down. So if I'm going to try to figure out what direction the acceleration is, I can say, well, to go from this to this, what do I need to add? Well, and honestly, it's probably best to go from one arrow to the arrow immediately following it. So I'll be a little bit more careful as I'm doing this. What does it take to go from this to this? Well, the difference between those two is an itty bitty bit going down. Yeah, if I add that arrow to that arrow, I get this. So it's kind of like saying, hey, this is my initial. This is my change in velocity, and that equals this, the final velocity. So the initial plus the change in gives me the final, and the change in velocity is proportional to acceleration. So I can think of it that way. So the change in velocity is always going down. That means the acceleration is always down, and the total force then is always down. So the arrow that I would add to represent total force would be, or net force would be, something like that. Something going down, and it's really just showing the direction throughout that motion.